This is a bleached reef. Not quite the same colourful shots you've seen so far this evening, but I guess reef is bleached because the temperature of the earth is increasing. The harder the water gets, the more often bleaching happens, and the worse off coral reefs like the Great Barrier Reef are. And obviously, by 2050, we're going to be seeing hot temperatures that are going to cause bleaching almost every year. But one of the unfortunate facts about global warming is that even though the mean temperature tends to increase slowly, monotonically, there are these variations around it. There are hot years, there are cold years, there are El Nino, La Nina cycles. And there's going to be some years well before the temperature of the sort of global average gets very hot, that spikes of hot weather are going to cause bleaching. We've seen them already. And basically, no matter what we do, no matter if the world gets together in Glasgow next year and decides to, get to zero carbon emissions by 2030, we're still going to have bleaching events on the reef. We're still going to lose the reef. And so the project that I'm part of, along with a large group from QUT and across Australia's universities, is to try to do something about these spikes before they happen. Now, one of the things we've got in mind is what you can see here. This is the North Atlantic. And these strange stripes of cloud that are crossing the ocean are in the wake of ships. So ships, particularly old ships, but even new ships, they burn fossil fuels and they put particulate matter into the atmosphere. And in a really clear marine environment, that causes clouds. And that's a useful thing, right? Because clouds reflect the sun, clouds reduce bleaching. And if the Great Barrier Reef at the hottest times of the year were covered by cloud, there wouldn't be as much bleaching. And so one thing that this reef restoration and adaptation program that we're all part of is trying to do is to produce these sorts of clouds, to take advantage of the natural physics of the marine environment to produce bright, reflective clouds over reefs in the weeks and days that they're most susceptible to bleaching, in those hot, still, clear, sunny days when the GBR can lose huge amounts of coral. Our hope is that if we can sort of harness this natural phenomenon, natural in the sense that it's caused by ships producing particulate matter that causes clouds, if we can produce these clouds at the right times and places, we can stop bleaching happening in the years and the sort of the places where it's going to be most severe. You can see here a person who's taking corals that are being grown in an aquaculture facility and transplanting them onto the coral reefs. And one of the other projects we're doing in the reef restoration and adaptation project is to try and grow large amounts of these corals, dozens, hundreds, thousands of hectares of these corals in a cheap and efficient way that we can deliver out to the reef so that when a bleaching event does occur that we can't stop, we can help the reef bounce back afterwards. And we're also, in an ideal world, hoping to engineer heat-tolerant, heat-resistant corals, hardened corals, so that as bleaching gets worse and worse, even in the best-case scenarios of global climate change, we can have populations and strains of coral that can resist the effects of future climates. And so the Reef Restoration and Adaptation Project, this whole sort of direct action approach to climate change, is saying, look, we have to deal with global climate emissions. We have to make sure that our carbon dioxide emissions worldwide and from Australia in particular reduce down to basically net zero levels by 2030. But even in that best case scenario, we have to take other steps so that the reef can survive even the best case scenario of what we've basically built into our environment from the industrial era of carbon emissions. And I guess the final thing I'd like to say is that technology is a wonderful thing, and if we can brighten clouds and engineer corals, then we could theoretically solve the problems that face the reef. But one of the nice things about this project is that, and I guess one of the essential things about taking conservation actions in any sort of realistic large-scale problem is it's not just a technological issue, right? Like we could engineer fantastic corals, but if we don't know where to put them, if we don't have a social license to deliver them to the reef, if people aren't willing to have them put out on the reef, and if we don't know where the best places are to put them, then it's worthless. And so, I guess any problem is not just a problem of technology. It's not just a problem that can be solved by the right robotics or the right remote sensing. It's a problem of social and I guess political will as well. And it's like a sort of whole series of steps that all have to be passed successfully before the problem can be solved. Thanks.